In our today's lecture, we will learn about orbital velocity and geostationary orbits. We will derive the equations that will relate the velocity of geostationary satellite with their radius. Okay, first here we deal with the expression for orbital velocity. Let's suppose this is Earth and this is a satellite which revolves around the Earth. The gravitational force provides the centripetal force for this satellite, and this satellite rotates around the Earth in a specific orbit. So according to gravitational law, we know that the force F is equal to G m1 m2 divided by r square. Here this G is the gravitational constant and its value is 6.673 multiplied 10 raised to a power minus 11 Newton meter square kilogram per kilogram square, where this m is mass of the satellite, where the r square is the distance of separation between the satellite and the Earth. Now from the definition of centripetal force, the force which compels a body to move in a circle is known as centripetal force. The centripetal force can be written as F is equal to mv square by r. Here this v square by r is actually the term for acceleration. So F is equal to mv square by r. Now we compare this equation number 1 with equation number 2. mv square r is equal to gm into m divided by r square. Here in this equation, this m will cancel out with this small m, and this m is the mass of the satellite. Here this r will cancel with r square and the v square will become equal to gm by r. Now taking square root on both the sides of this equation, we will get v is equal to under root gm by r, and finally v is equal to under root gm divided by under root r. Now here this term is constant and this velocity is inversely proportional to the radius or the distance of separation between the satellite and the Earth. What does it mean? It means if the radius is larger, then the satellite will slowly revolve around the Earth. And if this radius is smaller, this means the satellite must revolve faster around the Earth. Now this was simple expression which related the radius or the distance of separation between the satellite and the Earth with the velocity of the satellite. Now here we derive an expression for the geostationary orbits. When the satellite is in a geostationary orbit, then it completes one rotation around the Earth exactly in 24 hours. And from Earth, we see the satellite as stationary object in the sky. Similarly, in this animated video, you see the satellite. This satellite revolves around the Earth. When this satellite completes one revolution around the Earth also completes one revolution around its axis. So we know that v is equal to under root gm by under root r. Now we here substitute the value of s by t. v is equal to s by t is equal to under root gm by r. Here the distance s which the satellite covers is equal to the circumference of a circle. For example, this orbit is a circle, then its circumference will be equal to 2 pi r. Now in this equation we replace the s by 2 pi r divided by t is equal to under root gm by under root r. Now multiplying both sides with the t, this t will cancel with this t and we will have 2 pi r is equal to under root gm by under root r into t. And this t is the time during which the satellite completes one revolution around the Earth. So for a satellite to be a stationary object in the sky, we need the satellite to cover one revolution in 24 hours. So that as the Earth completes one revolution, so will the satellite complete one rotation. And we will notice the satellite as a stationary object in the sky. Now, solving this equation for r, we will get r square is equal to gmt square by r into 2 pi square. Here we have squared both the side of this equation. This under root gm become gm, this under root cancel with the square, this t becomes t square, and this under root becomes only r, this under root cancel with the square, and this 2 pi term becomes 2 pi square. Now multiplying both sides with r, we will have this r will cancel with this r and we will have r cube is equal to gmt square by 4 pi square. Now taking 1 over 3 power on both the sides, this 1 over 3 will cancel with this 3 and we will have r is equal to gmt square by 4 pi square whole power 1 over 3. Now this g is constant, this m is mass of the earth, and the value of mass of the earth is 6 multiplied 10 raised to the power 24, and this t square is actually 24 hours and there are 3600 seconds, so multiply 24 with 3600. 4 is constant and pi is 3.14. By putting the values of these all and solving for r, we will get this term, which is the stationary orbit, or we can write this term as 4.23 10 raised to the power 7 meter. You can also express this term in kilometers, which will be something about 4.23 multiplied 10 raised to the power 4. So this is the radius for a geostationary satellite. Thank you for watching and don't forget to subscribe EasyEDU for more videos. Comment your question.